our last presentation, this track, will be, again, something about MongoDB. MongoDB replication. Okay, let's hear what Mr. Krenn had to say about it. Please.
Hi, everyone. So, my second talk. I'm still from Vienna. So we are talking about MongoDB. The first talk I've held was about Morphia, which was the joy of development. The second talk is a bit more destructive. It's about the not so much joy of operations, probably, or at least the pitfalls. So, why would you want to use replication in general? Generally, the main argument is availability. So, if your main server falls over, another one will take over, and your application won't even notice and will keep on running smoothly. And secondary, data safety. If your first server dies, the data is still on the second and third server, so it's very hard to lose data if done correctly. And you can scale your reads because depending on how you configure your application, you can read from all of those servers. So you can probably get a very high read throughput. And it's helping with backups. So replication doesn't do or replace backups. It's just helping them because you can take the backups on the replications and you don't slow down your main server. It helps you in data migration. So if you want to add a new server to your configuration or you want to migrate to more powerful servers, you just add those new servers to the replication set. The data will be pushed there, and then you can just remove the old ones, and without any downtime, you can migrate to new hardware. You can also have delayed members, so if you do some stupid queries like drop a whole collection and you have a member running 1 hour behind, you can just get the data from that. And if you're developing with JavaScript, there are some nifty things there you can use, like oplog tailing with Meteor. So, how does it work in general? Terminology, we have a primary, we always have a single primary, and we have multiple secondaries where the data gets replicated to. So all the writes happen to the primary, and probably many reads, but the reads can also happen on the secondaries. However, you can never write to secondaries. Writes must always go to the primary. In the beginning, those were not called primary secondaries, but master slaves. However, slaves is somewhat problematic in the US, and so they've renamed everything to primary secondary. No, true story. That's a huge point of discussion sometimes with other systems. So how does it look like? You have your application on the top, and then it writes to your primary, and that just replicates your data to the secondaries. And even if that node dies, one of those two will pick up and be the new primary. So no chance to lose your data. Internally, those will ping each other every 2 seconds. So there is a heartbeat every 2 seconds. And when those two cannot reach the primary, they decide, okay, probably it's dead. And one of those will pick up. So there's nothing manual to do. It will all happen automatically. In that situation, all the servers have all the data. However, probably say, okay, we have so much data and we just want to keep it on 2 nodes. How is that possible? You always need an odd number of replica members just to form a majority, which we'll come to a little later. But you can have voting members, so the data will be only on the primary and the secondary, and this one is just there for voting and to break any ties if there would be an even number. So the data is just on 2 nodes. The big advantage of the arbiter is it needs very little space and it needs very little resources. So that's very cheap to run. So in the case your primary dies, only the secondaries get a heartbeat between each other, and one of them gets elected the new primary, and the other one stays the secondary. So that's just the regular error scenario. Limits. In the newest version, for I think 2 months ago or so, they changed that. Now you can have up to 50 replica set members. which should be more than enough. Previously, you could only have 12, which is probably also plenty, but you can only have 7 voting members. So, just to show you an example, I'll do a live demo. Let's see how much stuff breaks. So, let's see. Where's my mouse? I need the window. Okay, so just so I can see what I'm typing. I hope that's halfway readable. Okay, so to start the Mongo server, we just type MongoDB. Then you have, or let's start differently. I'll change to the desktop, and I'll create a new directory. Oops. And there I'll create a new Mongo instance now. So we have the MongoDB process. It needs a DB path. That's where the data will actually reside. Then we tell it to start on a port. And then it still needs a log path, which I call just log1. And oh, there is a space too much, sorry. Oops. It's really hard to read that actually.
There's a space between the DB.
Yeah, there's, but I don't see my cursor. There, okay. It's very faint. Oops, MongoDB DB path. There's a T missing at port. I killed that. What is it? No, that's not good. Mongo, sorry. Okay. MongoDB path 1 port. Log path. Okay. MongoDB path 1 port. Okay, my demo does not want me. Okay, so I guess we'll switch to an offline demo now. Give me a second. So we go back to the presentation. So okay, the color is really off. Okay, so in theory you would start your MongoDB process, start the process server, and then you log in on that port, and then you can just insert data. And if you call the test find, so that's your collection name, and you can just find all the data in that, so it will put back Philipp and city Vienna. If you then stop the instance and you add a replication, all you have to do is you create the other data directories, and then you start 3 processes. The same is still it's DB path 1, the port, so each gets its unique port, each gets its own log path, and we tell it it's a replica set, so all get the replica set with some name. The name is just arbitrary, it's just for humans. So if you run multiple replica sets, it's just that humans can better decide, okay, this is this replica set and this is that. That doesn't change anything in the configuration. And then we tell it, just use 20 megabyte extra of disk space, because otherwise it might be a bit greedy on the disk space. So if you start those and you connect to the first node, just like you did previously, and you run that query, you probably would expect that you get back the data, but that doesn't happen that way, because you need a bit more configuration. What you need is, on the first node you started, you initiate the replica set, so that's always replica set, initiate, and then you add the other node. So that's the host name of your machine, in my example, and that's the port. And that's all there is. And if you now run the find, it will put, or you will see the data that you previously inserted into the single instance. Now, if you connect to a secondary instance on the 2 or 3 port, one of those, and you run the query, you will see the data, you think, but actually it doesn't. Because in general, you can only write and read from the primary node, but you can enable reading from the secondary by enabling slave OK. So you can then read probably stale data from the secondaries, but you can read from the secondaries and not only from the primary. When you try to insert data on the secondary, it will just fail. That can never function. So you will always need to insert data on the primary, and you can probably read data from the secondary, depending on your configuration, but you can also read from your primary. If you kill the primary, then one of the other servers will just pick up. And whichever gets the new primary, that one will be able to accept writes. You can add writes. If you restart the old primary, it will come back up, see, okay, there's a new master, so primary, so I'm just a secondary, and then you see, okay, the new primary got new data, so I'm picking that up. And then also the old primary, which you killed in between, will get the latest data. And your whole replica set will again be in sync. So that's how that should work out. So the election part is still a bit fuzzy probably. The heartbeat is every 2 seconds, and if a node doesn't respond within 10 seconds, the others assume it's dead and will vote a new one. So your network should be pretty reliable, otherwise you will have often failovers. And there are election rules, so you have 3 rules which your election needs to follow. First, you can set a priority. You can say, okay, this node, in this example, that node has the highest priority, so if that's available, that will become the primary. If that one's not available, this one become primary. Node with priority 0 can never become primary. So you can pretty finely configure which nodes get primary or not. Then the uptime, that's just how long has the instance been running and how current is the data. And finally, connections. A node must be able to connect to the majority of nodes. So if you have 3 nodes, if you want to become primary, you need to be able to connect to one other node. So you have 2, the majority, against just 1. So you cannot, or you can never have multiple primaries. So the primary must be able to connect to the majority of nodes. That's also the reason why you should always have an odd number of nodes. So you cannot have a tie with 2, 2. So always an odd number, so either 3 or 5. So you can form a majority with 2 or 3 nodes. And then the new node says, okay, I follow all the rules, vote for me. And then the other nodes will say, okay, I will vote for you. But if they say, okay, you have old data or you don't have enough connections or something like that, they can also veto and then tell the node you cannot become primary, and then the voting process will start again. A node can only vote yes for one instance every 30 seconds. So there's this selection going on for 30 seconds. If the node can get the majority of votes within 30 seconds, it becomes the new primary. Otherwise, the connection will keep going on. So now you might be thinking, okay, everything is going good. Okay, those are Bill Gates and Ballmer, if you could see that. Okay, and so everything is working good. But probably everything is not working so well. You've probably heard of the CAP theorem, which says you can either have availability or consistency. The problem is the third thing, partition tolerance, is always there if you have a distributed system. So if you run more than one node, you will need partition tolerance. So you can either decide, do I want consistency or availability? The problem is, so MongoDB always chooses consistency. That's why you can only write to the master or the primary. And if you ask the primary for data, it will always get you back the current data. So that's why it should be consistent. The problem is, in some error situations, there can be a rollback. That data gets rolled back. You've written to some node because of an error state. For example, there's a primary. You write to that primary, but then the primary loses connection to the rest of the cluster before it is able to replicate its data. And then the primary, since it's separated, cannot be the primary, and the others will vote another primary, but they haven't received the new data, so that data is lost if it's just written to the old primary, if it cannot replicate the data in a timely fashion. The data is not entirely lost. In your database folder, it will create a file called the database name, the collection name, and the timestamp, and it will put all the data it basically throws away there, so you can probably pick up some data there. But if your writes keep on going, that's definitely not the situation which you want. Another problem is votes or elections can take up to 5 to 7 minutes. So normally they should happen really fast. So if your network is reliable and all goes well, you will have probably a downtime of 2 or 3 seconds until you have the new vote. But if stuff goes wrong, your application can be offline for up to 5 minutes or 7 minutes. So kind of the worst case that people have seen in the wild. And one other problem is, if there's already an election going on and the old primary still has some data it hasn't been able to replicate to the other nodes, and it's able to push that last update to just one other secondary. If that secondary doesn't become the new primary, it will need to roll back the data, because always the data from the primary counts. So you might be able to lose, or instead of saving some little bit of data in a failover scenario, you might lose the data if the wrong node gets a primary. Because remember, replication is asynchronous, and it's probably working something like that. It's just throwing out the data. What is really bad, if you have multiple primaries, in theory that should never happen, but there have been tickets that under very certain error scenarios it has been possible to have multiple of them. And then there is the very famous series Call Me Maybe from Kyle Kingsbury, who is torturing databases and trying all the error scenarios you can get. So he has tested a lot of databases, and the scenario for MongoDB isn't that nice. I mean, he did it more than a year ago, but he was able to lose up to 42% of the data he wrote to the database within a short period of time. Because the data was rolled back, and yeah, I know what you're saying, it's not an acceptable situation. The problem is, or MongoDB at least says, you're just doing it wrong, because you can configure a so-called write concern, where you can configure the durability of your data versus the performance. So you can choose better performance, but your data is not that safe, or you can choose more safety, but your writes will be slower. So it's up to you. You need to decide what's best for you. And for a long time, the default write concern was unacknowledged, which was basically like UDP, fire and forget. So you send the query, you're not sure the server can apply the query or anything. It's just, okay, I've sent the query, that was the default until 2 years ago, which was great in benchmarks, because the server never had to wait for the result. It's just, okay, I write the query, okay, I'm finished. Keep handing me stuff. But they had to change that because so many people were complaining, especially in combination with another feature. MongoDB needs to map all the data it has to memory. So if you're using a 32-bit machine, you were limited to something like 2.5 to 3 gigabytes of data. And in combination with that setting, you could keep on writing data. You would send data to the server, but it just wouldn't write it because it was full. It had its 2.5 gigabytes of data, and it just couldn't write anything else. But you wouldn't get back an error message because, okay, I sent the query, nothing happens, tough luck. Yeah, I know, not what you want. So the new default is write console acknowledged. The operation succeeded in memory, which means it isn't written to disk yet, but the server could at least apply the query. Now, if you write some data and immediately afterwards the server crashes because the power fails, the process dies, whatever, you could still lose data because it's just in memory and not yet written to disk. If you say, okay, I need more security, you can enable journaling, where you will write your data to disk in the journal file. And then, even if the server crashes, the data should be written to disk, and if the server comes back up, I could see, okay, there's something in the journal file, I still need to apply that to the database. You won't lose your data. So, if you need data safety, that's a good setting. You can even async it, so you write it to the correct position in the file system, but that's really slow and probably won't get you much. What is better is replica set acknowledged. So if you have a replica set, you can say, okay, I want to write the data at least for example, 2 nodes. So if one of those dies, the other one still has the data, which is probably a good setting for replication. The W is the server number, so you can explicitly specify how many servers need to write the data before the query returns successfully. And then there is the write concern majority, where if you don't want to do the math, you can still say, okay, just write it to the majority of servers. I don't care how many, depending on how many nodes are available, just write the data to them. Yeah. If you set write concern to majority, you won't lose data, or at least even Kai Kingsbury didn't lose any data with that setting, or hardly any data, because there was a minor bug, I think, which was fixed, but it should be fine. The problem is that's a lot of overhead. So instead of just going to a single server and writing the data there, you need to wait for multiple servers to finish accepting the write, which will slow down your application. So how much? There's been a benchmark by one of the biggest users of MongoDB server density. And you can see if with the fire and forget setting, it's nearly instantaneous if you write a bit of data. If you require the server to acknowledge the write, it's a bit more. The problem starts if you start writing it to disk. So if you enable journaling and write it to disk, the numbers just explode. And with writing to replication, it's still something like 4 to 5 times more extensive than writing to a single server, but it's still only a tenth or less of writing it to disk. So replication is much cheaper and probably as secure as writing to disk, or probably even more secure if your disk dies. But it's still a performance penalty you need to be able to pay. So depending on your situation, you might be able to lose data and it is not a big deal, but performance is more important. Then go with one of these settings. if the durability of your data is highly important, you probably want to operate with replica sets, or you want to write it to disk, but it's just expensive. Yeah, and those numbers don't really depend on the instance size. The slowest thing is the disk. Is that if the disk is slow, the writes will always be slow, even if you use really fast boxes. So that's basically it. Any questions? I have 3 more. Yes.
When we have 3 nodes, and in configuration, when we have 3 nodes and one fails, and there is election, and one is primary now, and there are only 2 nodes left. What then? It's not odd number of nodes.
No, but you start off with the odd number, so you have a majority afterwards. So out of the 3, if 2 can still connect, they form a new replica set.
Okay, but now you have only 2. When will?
Yeah, but that's still a majority.
Okay, majority. But you said at the beginning you need odd number of nodes.
You always start off with an odd number. So
Okay.
if 1 dies, you can still form a majority.
Okay, so it will work.
So that scenario will work. The problem is, if out of your 3 nodes, 2 will die, the last one cannot form a majority. Well, because 1 out of 3 is just not a majority, and it will stay a secondary. So there won't be a primary. In that case, you won't be able to write data to your replica set. Depending on your read settings, you might be able to still read data, but you won't be able to write. So in that case, if you need that kind of availability, you probably need 5 nodes. So out of 5, 2 can die, and then you still will be able to write and read data.
Hi. Can you turn back the slide with the statistics, with
Yes,
performance?
sure.
The numbers. So is this for all 1,000 inserts, or?
Yes, that should be for 3 times 1,000 inserts. That was done on Google Compute Engine, so the Google Cloud, but it's just the comparison how much performance you will lose.
So you had 3,000 inserts in under 1,000 milliseconds, 96 milliseconds.
Yes, that's what the test said. But those were very small documents, I think. So it
And
was
in all nodes.
Yeah, the birth thing is just a single node. And that's fire and forget. So you basically, you just put the network packet with the operation on the network stack, and then it returns. Because it doesn't need to wait for the server to respond. If the server needs to respond, it takes more than half a second.
I'm interested in when the data actually from time to time gets too big. What are the techniques for sharding or partitioning in regards to this master-slave architecture?
Right. So replication is for data safety, and then there is replication, which is the second concept. So you need to define a shard key, and based on that shard key, the data will be put on different servers. So you will have chunks of up to 64 megabytes, and once you reach that, it is cut. That piece of data is cut into the middle, into half, and put on different servers. That's also one of the nice thing if you try out sharding and test it yourself, and you don't put enough data into it, it just won't shard, because it will only start sharding at 64 megabytes. And that's one of the main beginner errors, when they just put in 10 megabytes of data and they say, my sharding doesn't work because it doesn't shard. But it's not expected to work like that.
One question regarding this statistical data. Is that data from a stress test or just initial 1,000 transactions?
Be careful with the word transaction, because there are no real transactions in MongoDB.
Yeah.
But I mean, I didn't do that test. I think it's a Python program, and he just wrote 3,000 documents. So it's just 3 times 1,000 documents.
Yeah, okay. I was interested in a scenario where you put MongoDB under a stress test to
You mean
test
what
continuously for like 1 or 2 hours under a different kind of loads.
What would you expect from that? So that the writes continuously start to slow down?
Yeah, exactly. Does it happen?
Well, obviously it depends. If you have a lot of data and you need to... So it will depend. If you always write new documents, it should pretty much stay the same because you just write them after each other. The problem is especially when you do updates and the documents grow, because a document needs to be in one place on disk. So if it grows beyond a certain limit, you will need to take the whole document and put it on another place on a disk, which is very expensive. MongoDB leaves some kind of padding, and it learns a bit how much padding do I need for these kinds of documents in general. But if you go beyond that threshold, it will need to take the whole document and put it somewhere else. That's expensive, and you should avoid it if you can. But otherwise, it shouldn't really slow down that much. I mean, for example, SSDs get slower the more the disk fills, so that might be a problem. So if one only got a few % of it, an SSD disk free, the performance should suffer. But otherwise, with a spinning disk, and you just append new data, I wouldn't expect it really to slow down. I mean, the number of connections are not expensive, or not really expensive, and they are pooled automatically, so that's also not a problem. So doing a longer load test shouldn't be that much of a problem. It just depends on the hardware, how much throughput you can get.
Okay, thank you very much.